Okay, our next topic is going to be that of exponents and roots. Okay, what an exponent is, and I know we've all probably seen them before. It's a little number up on the right-hand side of another number. So if I do something like this, for example, the exponent is that number 2. Okay, we would read this 10 to the power of 2. So another name for exponent is power. Okay, we say 10 is raised to the second power in this case. And what we're saying is we're going to take that number 10, which we refer to as the base, and we're going to multiply the base times itself so many times, in this case 2 times. Okay, exponents are all about taking some base and multiplying that base by itself a certain number of times, whatever time is up there in the exponent, or the power. Okay, 5 to the power of 3. 5 times 5 times 5. Okay, and of course that's just some number. In this case, 125. Okay? So whatever this number is, okay, even a power of 1, you know, if I take 8 to the power of 1, I mean, that just means 8 times itself 1 time, you know, not twice. That would be power of 2, so just 1. Okay, we usually don't write that exponent of 1, but every once in a while you see it there and you have to recognize that, hey, that just means 8. Okay, we'll talk a little bit later about what happens when we have an exponent of 0 or a negative exponent, okay, which does exist also. Okay, so second power, third power, first power. The second power and the third power have special names, okay? If I take 6 and I raise it to the second power, another way to say that would be 6 squared. I always forget if there's 1 R or 2 R's in squared. I'm going to put 2. I don't remember. Sometimes I just make it blurry so you can't tell. 6 squared. Now what is that coming out of? Which is, of course, 36, right? 6 times 6. That's out of geometry. If we have a square and it's 6, you know, whatever, meters on each side, and I want to find the area of that, it's length times width, but the length and the width are the same in this for a square, so it's 6 meters times 6 meters, which gives me 36, what we call meters squared, or square meters. Okay, so that term squared is kind of out of geometry when we're talking about taking a length times another length. Okay, it gives us a square length. Anytime you're talking area, you know, carpet or whatever, usually carpet's measured in yard. People get lazy, they drop the word square, they just say yards. Give me 10 yards of carpet. Well, that means square yards, okay? So area typically has that name squared attached to it. Okay, third power also has a special name. You know, 4 to the power of 3, we could read that as 4 cubed. Cubed, okay? What is that? Well, that's out of geometry also. If I take that 2-dimensional square and I turn it into a 3-dimensional cube, all sides being the same, let me go inches this time, 4 inches, 4 inches, 4 inches, and I want to find the volume of that cube. It's length times width times height. So I got 4 inches times 4 inches times 4 inches. 4 times 4 times 4 is 64, and then the unit becomes what we call cubic inches. Okay? Volume. Things in volume quite often have that cubic attached to them. You know, in the medical profession, cubic centimeters. They use the term cc, cubic centimeter. That's what it is. It's a measure of volume. 1 centimeter by 1 centimeter by 1 centimeter gives me a cubic centimeter. Okay, other things in the industry and things, you know, if you're a dumpster or something like that, if you're ordering a dumpster, they come in cubic yards. You know, give me a 30 cubic yard dumpster. Again, in the industry, people get lazy. They just say, give me a 30-yard dumpster. Well, they mean cubic yard. Okay, so volume has quite often got that measure of cube. Not always. I mean, gallons, liters, you know, we don't have the word cube assigned there, but there is a conversion to go from, you know, cubic inches to gallons, for example. They are compatible units, and there's a conversion to go between the two. Okay. All right. So far, so good with these exponents. Now, What happens though when I raise a negative number to an exponent? And here's where we need to be cautious, okay, especially with some calculators. And I don't know how the calculator on your exam is going to work. If I ask you to take, negative 2, no parentheses, to the power of 4, okay? In this case, the negative is not, I repeat, the negative is not being raised to an exponent. The negative's sitting there minding his own business, and I'm just taking 2 times 2 times 2 times 2. Okay, which is going to be 16, but there's a negative out front minding his own business. He's still there, so it's negative 16. Okay, we got to be very cautious about that. That's different from this. Negative 2 in parentheses raised to the power of 4. That means negative 2 times negative 2 times negative 2 times negative 2. Okay, and we learned from the previous section, when I multiply all these negatives together, if I have an even number of them, which I've got 4 of them, it's going to turn it into a positive. So that's going to be a positive 16. All right, so kind of a fundamental, profound difference between those two things. In one case, the negative does go along for what I call the exponent ride, and in another case, it does not. Okay, so that's a big source of mistake for a lot of people. Okay, when the exponent is odd, you get lucky. Okay, it's sloppy, but it's lucky. Let's say I have an odd exponent. Now, it doesn't matter if the base is even or odd or not. So the fact that I chose an odd number of 3 versus an even number doesn't matter. But the exponent, let's take that negative 3, no parentheses now, and let's cube it. That means negatives out front minding his own business. 3 times 3 times 3. Well, 3 times 3 times 3 is 27, but it's going to be negative 27. Okay? Now let's do it in parentheses. This time the negative does go for the exponent, right? Negative 3 times negative 3 times negative 3, I have an odd number of negatives at work, so the answer is going to be negative. So you see I get the same answer both times for different reasons though when the exponent is odd. In one case the negative did not go for the exponent ride, so that made the answer negative. In the other case it did go for the exponent ride, but there was an odd number of them, so it also was negative. Okay, so it's important we understand the difference there, okay, even though they're both negative. Even, however, you're not going to get lucky there, so it's best that we just understand, the rules and not have to rely on any kind of luck. Okay, so that's the gist with exponents. Watch out for the powers. If we have the number 1 raised to an exponent, 1 to the power of 4, sometimes people make a mistake and try to say the answer is 4. We're not multiplying the 1 times 4. We're taking 1 times itself 4 times. Well, that's just a good old 1, right? Negative 1 to the power of 5, okay? It's going to be negative 1 times negative 1, 5 times. It's still going to be a 1, but now I just got to remember my exponent rules here, so it's going to be a negative 1. And so if you ever get the power, 1 raised to some kind of goofy power, the power of 200 or something weird, it's just going to be a 1, because 1 times 1 times 1 times 1, same dealie. Negative 1 to the power of 34, it's an even exponent. I know it's going to be a positive number. Negative 1 to some odd power, power of 99, that's an odd power. I know it's going to be a negative 1. Okay, so watch out for 1 being raised to an exponent. Otherwise, we're taking that base and we're multiplying it by itself so many times. Okay, and that's really the gist of exponents. The reverse process of this exponent process is called taking the root of something. Okay, roots. Probably the most common exponent out there is the exponent of 2, the square exponent. And actually, before I dive into roots, let me go back. Let's look at the calculator. Let's look at the calculator. Now again, I don't have your exact calculator handy. Shame on me. And with my luck, I won't be able to pull it up on a quickie whim here either. I wanted to see how your calculator handles these exponents. If you could bear with me, I wish there was a way to pause this video. And I can't find one. I can stop it, but then that's the end of the video. I can't continue. Doing a quick search on my phone for that email that had your calculator, but on most calculators, okay, most newer calculators, see this little button here? It's like an upside down V. That's your exponent button. So if I wanted to take 5 and raise it to the power of 4, 5 exponent 4 equals 625. Okay, let's do a negative. And again, on this calculator, I put the negative in first. Negative 6 exponents squared. Now, I did not put a parentheses around that 6, so I should get a negative 36. And I do. If I want that negative to go along for the exponent ride, I need to open a parentheses. Put my negative 6 in the parentheses, and then raise it to my power, and now I'll get it, a positive 36. Okay? Okay, I'm getting close here. Bear with me. Come on, alright, I've got that email. Let's see what we're up against now with your calculator. First of all, almost every single calculator in the world has an X square button, because square is so popular. Okay, we're not doing roots yet here. Square is so popular. Let me see. Yeah, yours is more old school. See the X square button there? So, on your calculator, it's going to be kind of reverse. Okay, on my calculator, on a newer calculator, I would hit 2. Can't see what I'm doing, pardon me. I would hit, let me just see, some of these features might be the same. Yeah, okay. On this calculator, 5, hit my X square button, puts a little exponent of 2 there, and there we go. That's probably the same as yours. Okay, you will hit 5x squared, and then you'll get it. Okay, but any other exponent, if you look, you don't have. That's the only real exponent button you have, other than this button called x to the power of y. See that button there, x to the power of y. I don't have that button. I've got that upside down V looking button right here, and that's what a lot of the more modern calculators have. So we got to watch out for that one. How you would enter it. You would probably, my guess, and you should verify this, is if you would put in the number, let's say I wanted to do 5 squared. I'm going to put the 5 in, then I'm going to hit X to the Y button, and then I'll put 2 in. Okay, I'm not 100% certain on that. But that's probably what you have to do. And then hit, your equal button or your enter button. I think that's what you're going to have to do. So that's how you would do 5. Now, if you're doing square, of course, you can just use your X square button. But this is a generic root for any root. If I wanted to do 5 to the power of 3, I have no other option but to do it that way. Okay, and I'm guessing a little bit here. I do not have this calculator, but I'm guessing that that is how you would have to do it. So again, it would be great to play around with this calculator. If nothing else, watch a YouTube video about it. It's this FX260 Solar. If you didn't watch my little previous calculator video, there are some differences between this calculator and a lot of the ones you would go out and buy, kind of on the street these days. And that's probably one of them, how we're going to do this exponent button. Okay, root button. We're going to talk about roots here in a second. You got that square root button there above the X square button. A little square root symbol. We haven't talked about that yet, but that's a square root symbol. Okay, and again, how do you do it? I think on this calculator, you would type in, let's say I want to take the square root of 25, you would probably type in the 25 first, and then you're going to have to hit that shift key, which gets you to that character, so then shift, and then the X square button, because the shift gives you the square root symbol on top of the X square button, and then equals, okay, and it will give you the answer. On these other calculators, you hit the square root symbol first, okay. So if I do that, it shows me the little symbol on my screen, and then I would put my 25 in there. Oops. Well, 5 will give me a goofy decimal, but that's fine. Okay, 2.2, blah, blah, blah. That's the square root of 5, okay? These are probably a little backwards on the rooting. Okay, so let's talk about roots. The reverse process of squaring, and the most common root is a square root. Okay, reverse process of squaring. 5 squared is 25. Okay, the square root process is just going backwards. If I want to take the square root of 25, it looks like that. It's a little symbol here. I put the 25 in there, and that gets me back to the 5. Okay? Now, if we were going a little deeper into the math here, we would learn that there really are 2 answers to this problem. What is the square root of 25? A positive 5 and also a negative 5. Okay? Because if I take negative 5 and square it, I also get a positive 25, don't I? Negative 5 times negative 5 is positive 25. So when I'm going back the other way, there's really 2 answers. Okay, and in the world of math, we would call that a positive or a negative 5, and that's kind of the shorthand way to write it. Okay, but from what I can tell, anything you would have to be worried about for this exam just is talking about the positive root, which we call the principal root. I always forget which principal it is. That's probably the wrong one, but I'll go with it. The principal root, okay? The positive root. So we just need the positive. And that's what your calculator is going to give you. Okay, so think of the reverse process of squaring. 6 squared equals 36. So if I want to go back the other way, the square root of 36 equals 6. It's helpful to have the first handful of square roots kind of memorized, you know. If you have the first handful of squares memorized, 9 squared is 81. So if I want to go back the other way, square root of 81 is 9. Okay, what about the square root of 80? Well, that's just going to be some decimal. Okay, it's going to be a little bit smaller than 9, 8 point something. Okay, I don't know what it is offhand. That's where we rely on our calculator here, and again, mine will be a little different the way I type it in with the square root of 80. Some goofy decimal, 8.94, blah, 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 okay? You may be asked to evaluate a root like that, and then it's going to be some decimal. That's all, you round it off somewhere, okay? So that's the basics of a square root. If I tried to take the square root of a negative number, I'm going to be in trouble. Okay? Because when I square something, I always get a positive, right? And even if I square a negative number, I get a positive answer. So, there's no way to get a negative 25 out of this process up here. So, how can I possibly start with a negative 25 and try to go backwards? Okay? Your calculator is going to give you an error message, and I don't know what the message is going to be, quite honestly, especially on that calculator. Let me see what it is on mine. Square root of negative 25 equals, domain error. Okay, fancy. Okay, some kind of error message. That's what takes us into the world of what we call imaginary numbers. Okay, we're not going there in this course. So we can't take the square root of a negative number in our course. Okay? Alright, some properties of roots here. If I have just basic operations under what's called the radical sign. Okay, a little terminology. This big thing's called the radical sign, and I could have stuff cooking underneath the radical sign. Like I could have a 36 plus 64. Okay, and when I have things added together like that, there's no way to really break them apart. So I just have to figure out what is 36 plus 64, and I say, okay, that's 100, and now I'll take the square root of 100, which gets me to 10. Okay, so if I have something like that, some process underneath inside the radical sign, then I have to just do that process. Okay? Maybe I'll have radicals added together. Maybe I'll have the square root of 49 plus the square root of 16. Well, that's no big deal. The square root of 49 is 7, the square root of 16 is 4, and then I'll simply add them together and get my 11 out of the deal. Okay? maybe I have a fractional square root. Oh no. Oh yes. Square root of 1 over 25. Well, when we have a fraction, which is a division problem, we can break it up into separate little square roots like that. Well, now it looks easy. The square root of 1 is 1, the square root of 25 is 5, so that's 1/5. Alright, so if we have things that are divided like that, a fraction is just a division problem, we can break it up into two little separate fractions. We'll learn more about that here in a moment. Okay, the other way to think about it though is just, 1/5 times 1/5 gave me that 1/25, didn't it? So going back the other way, so in other words, 1/5 squared gave me 1/25. So going back the other way, the square root of 1/25 gives me the 1/5. Just going back the other way. Okay, what about higher roots? That's square root. What about, isn't there an opposite of the cubing process? Yeah, that's called the cube root, or the 4th root, or the 5th root, or the whatever root. Okay, I don't know how deep you may be required to go on the exam, but let's take a look at what we have for options here. Get your calculator back out here. You should have a generic root button on here. And you do. Ooh, you actually have, it looks like a cube root there. See the little 3 on the ledge there? Cube root. The cube root of 8, for example. Well, I got to think reverse process of cubing. What times itself again gave me that 8? Well, it'd be a 2. Right? Because 2 to the power of 3 is 2 times 2 times 2. That's where the 8 came from. So if I want to go back the other way, I take what's called the cube root of 8. And that'll get me back to the 2. Okay, so it looks like there's a little 3 on the ledge there. And that's your cube root button. Okay, on this calculator. Most calculators, or many do not have the cube root, but most have a generic root button. Yeah. And it's hard to see, but if you look above your generic exponent button, x to the power of y, that's your generic root button. I'm sure it is. Okay, so you have to put in what's called the index of the root. So you would probably, with this calculator, speculating a little bit here, but with this calculator, let's say I want to take the cube root, so I probably have to type in on my number 3 first, and then I need to activate this button, which requires a shift key. Okay, and then my y to the power x button to get me up above there to that function right there. So 3 and then that button, so that's going to give me what's called the index of the root. So now I want to take the cube root of what? Let's say 27 in this case. Okay, the cube root of 27, and then I'll hit my equal button, and it should give me a 3 because 3 cubed is 27, so the cube root of 27 gets me back to the 3. Okay, so I'm fairly certain that's how you're going to be able to do a cube root with this calculator. Okay? How would I do it? You got to remember, what do I got on my calculator? It's probably very similar, but again, mine, I'm going to probably enter it a little differently. Where is my generic root button? Yeah. Remember, my exponent button here is an upside down V, so the generic root button's above it. I probably have to put the index in first too. So 3, hit my shift button, and then, let me see if it works. Pardon me for not knowing. Yeah, okay. 3, my generic root button, and then the 27, and then enter, and it gave me the cube root of 27. Okay? Okay, we're going to do more kind of work with roots. There's probably not a tremendous amount of roots on your exam, but I do want to go over some quick properties of these radicals. How do you add, subtract, multiply, and divide? Because if it shows up, you want to be on top of it. So the next video, I'll run through some of that stuff.